Hello viewers and my dear students. A warm welcome to VR Ticket channel. Let me introduce myself. I am Varlakshmi BS, DFA, BE, MTech Gold Medalist. I completed my engineering under VTU in Electronics and Communication and I pursued my PG in two different domains. Mechatronics under VTU, Electronics and Communication under JNTU. I have 7 years of experience in teaching. The main motto of our channel is to share knowledge and make students to understand the concepts in easy and effective way. So, let's join hands together and spread the knowledge to the maximum. Kindly support us, like, share, comment and don't forget to subscribe our channel. Thank you. Gurubhyo Namah. Hello students, let's start the class. Today's class is on matrices. So, what do you mean by matrix? An ordered rectangular array of numbers or functions we call it as matrix, right? An ordered rectangular array of numbers or functions we call it as matrix, usually arranged in the form of rows and columns, right? And matrices are always represented with capital letters, right? And it is enclosed by brackets and always with the order. Usually we call this or read as m by n, where m is number of rows and n is number of columns. Right? Let's try to write the generalized. Let us consider a matrix A with this is first row, first column element. Similarly, first row, second column element. If we continue, we know it is n cross n, right? So, first row and nth column. Similarly, second row, first column, second row, second column, second row, third column, so on. If we go, it is mth row, nth first column, mth row, second column, nth row and n column. This is the generalized form of matrix which consists of m number of rows and n number of columns. Right? Usually this is represented as right. This is the generalized form of representing a matrix. Now let's see the types of matrix. Also, you should know that whatever the numbers or entities we call in matrix, it may be real or complex. Okay. So, the simplest or simple matrix, we started from row matrix, column matrix, rectangular matrix, square matrix, diagonal matrix, scalar matrix, identity identity or unit matrix, zero or null matrix, triangular matrix. Again in this, it may be upper triangular matrix or lower triangular matrix. These are the important basic types of the matrix. Let's see each in detail. One, two, three, four. So here we have only one row and 1, 2, 3, 4, 4 columns. Matrix which consists of only one row and n number of columns. It may be 4 columns or it may be 5 columns and so on, or it may be n columns in generalized form. Right? Because matrix is always represented as in this form, right? So for a row matrix, m is always equal to 1. Right? N, it may be 1, 2, right? This we call it as row matrix. Column matrix. In column, we have only here we can see 1, 2, 3, 4. We have 4 rows but only one single column. In this case, if we link with this, m may be 1, 2 until m, but n is always equal to 1. Right? So, the matrix which consists of only one column and n number of rows, we call it as column matrix. This is row matrix and this is column matrix. Understood? Now let's see. Consider this matrix, say M, which is equal to 2, 3, 5, 6, 1 and minus 1. Right? Here there are 1, 2, 3. This is 1, 2, 3 and 1, 2. We have 3 rows and 2 columns. Here we can see M is not equal to N. In a matrix, if M is not equal to N, then such matrices we call it as rectangular matrix. Okay. Consider the same matrix with other example. I'll just write here 2, 4, 6 and 8. Here we have 2 rows and 2 columns. This is just an example, right? If number of rows is equal to number of columns, then we call such matrices as square matrix. Such matrix we call it as square matrix, where the number of rows is equal to number of columns. Okay. Further, consider a 3 cross 3 matrix. For an example, say this is first row, first column. Right? Right? Since here in this matrix the number of rows are equal to number of columns, right? So this we call it as a square matrix. Square matrix, right? Then if in the elements we call it as principal diagonal elements. Other elements other than principal diagonal elements we call it as non-principal diagonal elements or entities, right? So in a matrix, non-principal diagonal elements are all equal to 0. Such matrix we call it as diagonal matrix. Understood? Consider an example. If I take this is an example where it consists of 3 rows and 3 columns. Right? Since number of rows is equal to number of columns, this is a square matrix, and since the non-diagonal elements, that is other than this principal diagonal elements, all elements are equal to 0. So such type of matrices we call it as diagonal matrix. Understood? If in a diagonal matrix, if all entities, that is if all principal diagonal elements are equal, then we call it as scalar matrix. Say, consider this example. If this is right, so again this is 3 by 3 matrix. 3 number of rows are 3 and number of columns are also 3. Definitely it is a square matrix and definitely it is a diagonal matrix. Why? Because other than principal diagonal elements, all elements or entities are equal to 0. But since the principal diagonal elements are all equal, that is, if we generalize to the generalized form, A11 is equal to A22, which is equal to A33, that is equal to 2. Right? Then such type of matrix we call it as scalar matrix. Understood? Hope you understood the difference between square matrix, diagonal matrix and scalar matrix. Both diagonal and scalar matrices are obviously square matrices. But only difference is in diagonal matrix, other than the principal diagonal elements will be equal to 0. But in scalar matrix, the principal diagonal elements will be equal. Right? Unit matrix. Unit matrix usually we represent it with capital letter I. Okay. That if we take 3 by 3 matrix, consider this example. You can see here, unit matrix is a scalar matrix. Definitely. Why? Because m is equal to n and all entities are equal to 1. But also it is the entity is equal to 1 number. It means the principal diagonal elements are equal to 1 if all the principal diagonal elements are equal to 1, then such matrix we call it as unit matrix. Okay. Now comes zero matrix or null matrix. Usually represented with capital letter O. In this example, all elements will be equal to 0. Again in null matrix, there is no necessity to be m is equal to n, or it may m not equal to n also. Depends on the order, right? But the only condition is all the entities. You can see all the entities should be equal to 0, right? Now consider an example. I'll just give 0, 0, 0, 0, 0 and 1. Is this a null matrix? Definitely no. Why? Because here the third row second column element is 1, and thus this matrix is not a null matrix. Hope you understood the difference. So for a matrix to be a null matrix, each and every entity must be equal to 0. Now triangular matrix. Consider an example. If I take 1, 0, 0, right? Here this is the principal diagonal elements, and other than principal diagonal elements, these entities are 0. So this is lower triangular matrix. Why? Because the upper triangular section of the matrix, all the entities are equal to 0. In general, you can say that here Aij will be equal to 0 for all I. Here you can say this is first row, second column. This is first row, third column. And this is second row, third column. Here you can see is always I will be less than j. Here I is 1, j is 2, I is 1, j is 3, and again here I is 2 and j is 3. For a matrix, if Aij, that is the element or the entity, is equal to 0 for all I less than j, then such type of matrix we call it as lower triangular matrix. If we get a matrix like this, right? In this example, we can see this is the principal diagonal elements, and the lower section of the triangle, that is lower part of the principal diagonal elements in a matrix, are equal to 0. These part is all the entities are 0. Such type of matrix for where Aij is always equal to 0 for I greater than j. Such type of matrix where the lower portion of the principal diagonal elements will be equal to 0. Such matrix we call it as upper triangular matrix. Understood? Call trace of matrix. Usually represented as some matrix C. If we consider this, the trace of matrix A, here we say it as this. So from this you can tell that the trace of matrix is nothing but simply the sum of the principal diagonal elements. Sum of the principal diagonal elements, or in general we can represent it as it is A of ij where I is equal to 1 to it may be till n. Because again we can see that I is equal to your j. Understood? So this we call it as trace of a matrix. These are the types of or basic types of matrices one should have a knowledge about it, or basic information about these matrices you should have in order to solve matrices.